Hi everyone, this is the second video for day 3. So let's look at what can be solved using sine law, what cannot be solved. Now recall when we did trig ratios, with trig ratios, we said for any triangle there are 6 parameters, right? There's 3 sides and there's 3 angles to any triangle. So the problems that we worked with right angle triangles, you would be given 2 sides or 1 side, 1 angle, and you have to find a third thing. So there were various possible combinations of what could be given to you. So now let's look at what if it's an oblique triangle. Now if it's an oblique triangle, ABC, ABC. So what we have are these equations: A over sine A, B over sine B, C over sine C. That's all we have, right? Now let's look at one pair of this equation. Now there are 4 things here. So out of the 4 things, 3 needs to be given. So I can find the 4th. If I don't have 3 out of these 4, or 3 out of these 4, or 3 out of these 4, then I'm not able to solve. Right, so for example here, if I'm only given 2 sides, I cannot solve. I have to be given 2 sides and the angle inside. Okay. Now what if A, B and C, the angle C are given? That's still an issue, because if I have these sides and I have this angle, then there's no way to solve, because I have 2 pieces of information in this equation and 1 in this equation. So no matter what pair I take, right? If I take A over sine A equals B over sine B, or I take B over sine B equals C over sine C, or I take A over sine A equals C over sine C. Here I know 2 things, so not enough. Here I know 2 things, again not enough. And here I know 2 things, which is again not enough. So I can't use sine law. So if you are given 2 sides and the angle included in that side, then you cannot use sine law. The next scenario is if you are given 3 sides. Yeah, so you know ABC, but you don't know anything about the angles. And you can again verify, no matter what set of equation you use, you only have 2 things. So that's not going to be enough. So again, you can't use sine law. Okay, so keep this in mind. There are 2 scenarios here that we found where sine law cannot be used. In day 4, we learned another law called the cosine law, which will complete our set of tools, because that means cosine law can be applied for these 2 scenarios. Alright, now one last comment on sine law is there's a situation called an ambiguous case. So let's sort of try to solve this problem. It says there's a triangle that has a 1.5 inch side and a 2.5 inch side. So let's draw something like that. So this is 1.5 inch and 2.5 inch. And an angle of 32 degrees, which is opposite the 1.5. Try and solve this triangle. So this is 32 degrees. Alright, let's label them. I don't know anything about this third side, so let's see what I can find. I have a side and the opposite angle, an unknown side and this angle, right? So I can still go ahead and I can go 1.5 over sine 32 equals 2.5 over sine c. Cross multiply 1.5 sine c equals 2.5 sine 32. Sine c equals 2.5 sine 32 divided by 1.5. Now what does that come out to? 2.5 times sine 2.5 sine 32 divided by 1.5. This gives me 0.8832. Now at this point, remember, if you have sine c, you can find the angle by using the inverse function. So sine inverse of 0.8832 is 62.03 degrees. So I can find that to be 63.03 degrees. Okay. Now, here is a situation where we have to go back to the graph of the sine, right? Okay. Now this is saying that when you have 62.03 degrees, the value it gives you is 0.8832. But because of the nature of sine, it repeats the values, right? So there is some other point here which also gives you the same answer. So C could be another number. In fact, in this particular situation, you can have two diagrams that are possible. So there is this diagram, and they're both going to satisfy all the conditions. This is the condition of the problem, right? But that's the first diagram we made. But there's also another possibility. There is a possibility that I have an equal 1.5 degree here, and I have this other triangle. This is because I know nothing about the length of the base. And in this case, this angle is going to be greater than 90 degrees, which sort of makes sense based on this graph here, because this other answer, I expect it to be more than 90 degrees. Okay, so this is called an ambiguous case. Okay. Now, when is this ambiguous case possible is when this side length is small enough that you can fit another one here. It's beyond the scope of this course to talk about how you can check for that, but you still need to be aware of the possibility that this can happen. One of the worksheet problem asks you to make another example of your own. So what you can do is you can play around with these values and see where such a construction would be possible. Okay. Now, of course, for example, if this side is very long and this side is not very long, right, then you cannot fit another one in here. So play around with these values and see if you can figure out another example for the worksheet problem.